Hello everyone, I'm Dr. C. Shanti, Professor and Head of the EC Department, Government College of Engineering, Srirangam. In this video, we are going to see the fundamentals of data structures in C programming language. First of all, what is a data structure? A data structure is a collection of data values and the relationship among them and the operations that can be applied to the data values. This is very essential for data organization, data management, and for data storage, and this which enables efficient access and modification of this data value. Before going into the structures, we should learn the C programming, which is the basic tool for the above operations. First, let us see the structure of a C program. To learn the structure of a C program, a very simple C program which print an integer value 10 on the screen. It is a 5-line program, and the first line represents the header file, and the second line declares the main function, and the third line represents the integer variable A, and the fourth line is a printf function, and the fifth line is a return value. And now let us analyze this structure of this program line by line. The first line, which is hash include stdio.h. In C program, all lines start with a hash symbol or processed by preprocessor, which is a program invoked by the compiler. Compiler is which converts the high-level program into a machine-readable program. The .h files are called header files in C, and these header files contains the declaration of functions like a printf, scanf, which are library functions used in the program. In the above example, the preprocessor copies the preprocessed code of stdio.h in the main file. There are so many header files are there. Some of the main header files are stdef.h, which defines the several useful types and macros, stdint.h, which defines the exact width of integer types, and stdio.h, and it defines the core input and output functions, stdlib.h, it defines numeric conversion function, pseudo-random network generator, and memory allocation. And string.h, it defines string handling functions, and math.h defines common mathematical functions. And the line 2 is the declaration of the main function. The syntax for this main function is the data type int main with the two braces. All execution begins with first line of function main. The int written before main indicates the return type of function main. All functions must start and end with curly brackets representing the scope of the main function. And the third line is the declaration of the variable. Here the variable is an integer variable. So the syntax is int a. And a numeric value 10 is assigned to the variable a. So int a assigned 10. In C program, no variable can be used without being declared. A variable is the name of the memory location which holds the value assigned to it. It is used to store the data value. The variables are to be declared before any operation in the function. The semicolon at the end of the statement indicates the line termination. And the fourth line is the printf function, which is a standard library function and which is declared and defined in the stdio.h header file. And %d is the format specifier to print the integer value of a. So a simple a 3-line program is given here. Integer main within brackets, void is given here. Void means this main function does not take any parameters. Sometimes function takes parameters. So here it is not taking any parameters, so it is given as void. The next, integer a assigned 10 and print a function with the format specifier and the integer variable a. And the last line is the return statement, which returns the value from main function. The returned value may be used by operating system to know the termination status of the program. The value 0 typically means the successful termination of the main function here. So a simple program is given below. Here the return 0 represents the successful termination of the main function. And the next process is the compilation process, which is a background process which converts the source code, which is written in high level language like C, into an object code, a machine readable code, as shown in this figure. The compiler checks the source code written by the programmer for syntactical error and structural error, and if the source code is error-free, then it generates the object code, which can be executed by the computer. And the compilation process can be divided into 4 steps: pre-processing step, compiling, assembling, and linking. The preprocessor takes the source code as an input and it removes all the comments from the source code. The preprocessor takes the preprocessor directive hash symbol and interprets it. For example, hash include stdio.h in our program. The preprocessor interprets the directive and replaces this directive with the content of the stdio.h file, where the input function and scanf functions are defined. To understand this compilation process, a very simple example is given here. Here, hello.c is the source code, which is written in C language. It is only a 4-line program which print hello on the screen. Okay, when this source code is given to a preprocessor, the preprocessor generates an expanded source code by including the stdio.h file in the main file, and the expanded source code, the file is hello.i is generated. Actually, the source code is hello.c. After pre-processing, it generates hello.i. And this hello.i is given to a compiler, and the compiler generates an assembly code that is hello.s. And this hello.s is given to an assembler which generates hello.obj, which is an object code. And this object code is given to a linker, where the linker links all the objects file and other files relevant to this program, and it produces an executable code that is hello.exe. This exe file is loaded and then executed. So this is the basic structure of a C program and the compilation process. And next comes the constant. Constant is also one of the important feature in C programming. The constants are fixed values. It values remains the same during the entire execution of the program. Constants are also called literals, and it can be of any data type. Generally, we use uppercase letters to define constants. The syntax for defining a constant is constant. const is the keyword which defines a constant, and the type is the type of the constant, whether it is an integer or a character or a float, and a constant name. As I said, constant name is generally represented in uppercase letters. Okay. The simple program, here there is a simple program to calculate the area of the square with side. Here the side is declared as a constant of integer type. A value 10 is assigned to it, and the area is calculated, and the output is generated as the area of the square with side 10 is 100 square units. It's a very simple program. And we can put the type either before the keyword constant or after the keyword constant. Both way are correct. Constants are categorized into two basic types as numeric constants and character constant, and each of these types has its subtypes. For example, numeric constant has integer constant and real constant, and character constant has single character constant, string constant, and backslash constant. The numeric constant, the first subtype is the integer constant. It is nothing but a sequence of digits. Integers are of three types: decimal integer, octal integer, hexadecimal integer. So the example for each type is given here. And real constants are nothing but they will have fractional parts like 24.12, 99.25 are called real or floating point constants. And in character constant, single character constants are represented by a pair of single quote. We should know the difference that the character represented within a pair of single quote is not same as the character simply given. Here 8 is represented within a pair of single quotes. So this is totally different from 8. First one is the character constant. The next one is an integer value. Character constants have a specific set of integer values known as ASCII values. ASCII means American Standard Code for Information Interchange. As I said, the character constant, single character constants are always given within as a pair of single quotes. And a string constant, here a sequence of characters enclosed in double quotes, and they may include letters, digits, special characters, and blank spaces. It is again to be noted that if any character is given within a pair of quotes is different from the same character represented with a pair of single quote. The character given within a pair of double quotes is a string, whereas the same character given with a pair of single quote is a single character constant. And the third type of character constant is backslash character constant. It supports some character constant having a backslash in front of it. The list of backslash characters have a specific meaning which is known to the compiler. They are also termed as escape sequences. For example, /t is used to give a tab, /n is used to give a new line, and a /a used to give a beep sound, and a /b used to give a backspace, and a /f used to give a form feed, etc. A /0 used to give a null value. And next comes the keyword. A keyword is a reserved word, cannot be used as a variable name or constant name or a function name, etc. In C, we have 32 keywords, and they are given below. For example, auto, break, case, character, constant, continue, etc. And C also have identifiers. Identifiers are user-defined words to represent variables, functions, arrays, etc. And it includes 63 alphanumeric characters. In this 63 alphanumeric characters, 52 alphabetical characters or uppercase and lowercase letters, and underscore is also included, and 10 numerical digits from 0 to 9. So all these 63 alphanumerical characters can be used to construct identifiers. There are certain rules in constructing the C identifiers. So we must remember these rules when we construct the identifiers. The first character of an identifier should be either an alphabet or an underscore, and then it can be followed by any of the character, digit, or underscore. It should not be begin with any numerical digit. An identifier, both uppercase and lowercase letters are distinct. Therefore, we can say that identifiers are case sensitive. Commas or blank spaces cannot be specified within an identifier. Keywords cannot be represented as an identifier. The length of the identifier should not be more than 31 characters. Identifier should be written in such a way that it is meaningful, short, and easy to read. And the differences between keyword and identifier is given in this table. A keyword is a predefined word, whereas the identifier is the user-defined word. The keyword must be written in lowercase letter, whereas the identifier can be written in both lowercase and uppercase letters. The keyword is predefined in the C compiler, whereas the identifier meaning is not defined in the C compiler. The keyword is a combination of alphabetical characters, whereas the identifier is the combination of alphanumeric characters. The keyword does not contain the underscore character, whereas the identifier, it can contain the underscore character. So in this video, we have seen the structure of a C program and what is a constant and its different types and the difference between the keyword and identifier. In the next video, we'll see the data types and variables used in the C program. Thank you.